Okay, this is the algebra homework from before. I'm going to go through it fairly quickly because my camera's running out of juice. So, A and B. A is directly proportional to B. A equals KB. Plug in 15 and 3. A is 15. B is 3. And lo and behold, it's pretty obvious that K must be 5, right? So then you rewrite A equals KB, replacing the K. Find A when B is 7. A equals 5 times 7, which is 35. Find B when A is 5, so we get 5 equals, K is 5 times B, A equals KB, and A is 5, and K is 5, so B is clearly 1. That was easy. Okay, B is inversely proportional to the square root of n, so P is inversely proportional to K over the square root of n. When n is 9, P is 30, so we say 30 is K over root 9, which means that 30 is K over 3, which means you multiply across and K is 90. Sorry, I was about to write K equals 90 is the answer. And then you replace K in the equation, so P equals 90 over root n. When n equals 4, so we start off with our formula, P equals 90 over root n, but n is 4, so P is 90 over root 4, so P is 90 over 2, which is 45. And then find n when P is 18, so P equals 90 over root 10. 18 equals 90 over root 10. This routine that you're familiar with now, I hope, the switcheroo. Root 10 equals 90 over 18, which is 5. So therefore n is 5 squared, which is 25. Rearrange for A. So we get the terms containing A by themselves, need to add that B over. M plus B equals AT, and now divide by the T. B equals root AM. We've got the square root by itself, which is good, so now we unsquare root, and we get B squared equals A over M. You square to unsquare, and then times the B over, it's B squared M, not B times M, please, because we don't need to say times in algebra. Now we've got A appearing twice, so we need to get all the A terms on the same side, so we add the AR over, and we get AM plus AR equals T, and then factorize out A times M plus R, and divide by that. And slightly more complicated, but the same idea, multiply all this out. Get the terms containing A on one side, so we'll minus AB, and add 2W. Could factorize this, but not necessary. Let's get the A factorized out, and then divide across. Some people got the minus of this on the top over B minus 2. Don't worry, that means the same thing. Next one. Simplify. It's all factorized, so we can cancel. The x's go. 4 over 8 leaves you 1 over 2. And so we've got 1y over 2, but you can't write 1y. It's just y over 2. This one you can't cancel because there's an x by itself. So that means we need to factorize first. X comes out, we have x times x plus 1. And now these x's can cancel, leaving us with just x plus 1. We're adding, so we need a common denominator. Lowest common denominator of 6 and 3 is 6. We get x over 6 plus what over 6? Well, we doubled that to get 6, so we double that, we get 4y, and now we can click them together because they're the same denominator. So we get x plus 4y, 1 over 6. Here we've got 3a and 2a, so the lowest common denominator is 6a. How do we get from 3a to 6a? We double it, so we double the top. How do we get from 2a to 6a? We triple it, so we triple the top. And we take away 3 when we click them together over 6a, which is just 5 over 6a. Here, lowest common denominator is 20, so we multiply this by 5. We get 5 lots of x plus 1 over 20. And multiply this by 4, top and bottom. Got to be careful here because we can see that minus is going to create a problem soon. So this is 5x plus 5 over 20, and this is 4x minus 8 over 20. But of course, when we put them together, now the minus takes effect. So we get 5x plus 5 minus 4x minus 8, which is plus 8. And so we end up with x plus 13 over 20. 2x plus 3 over 4 equals 5 times the 4 over. Minus 3. Divide by 2. These two you can cross multiply when we have fraction equals fraction, so that goes there, that goes there. 3x minus 3 equals 8x plus 16. And then put the x's on one side, put the numbers on the other. We subtract 3x, we have 5x. We subtract 16, we have minus 19, so x is minus 19 over 5, or minus 3.8. And here, this is a bit complicated. We need to put the, well, there's different ways of doing this, but I would put the fractions together. So put that over 10, put that over 10, so we multiply that top and bottom by 5. Multiply that top and bottom by 2. And then because it's a minus, we're going to have 5x minus 2x, which is 3x, and minus 10 minus minus 6, which is minus 10 plus 6, so minus 4. This is all equal to 4 still. Now, because it's a single fraction, multiply the 10 over, add the 4, and divide by 3. 4, 3 equals 14 and 2/3. Very nice. Okay, some more nasty algebra. Here, again, no common factors, so we just have to multiply them. So it's going to be x plus 1, x minus 2. Multiply this one to get from x plus 1 to x plus 1 times x minus 2, we multiply by x minus 2, so this could be 3 times x minus 2. And to get from this to this, we need to multiply by x plus 1, so this could be 4 times x plus 1. Which means we have 3x minus 6 plus 4x plus 4 over that complicated denominator. 3x plus 4x is 7x, minus 6 plus 4 is minus 2, so it's 7x minus 2 over x plus 1x minus 2. When we divide, you flip the second fraction and multiply, so we get 3 over x plus 1 times x minus 2 over 4. 3 times x minus 2 gives us 3x minus 6, and 4 times x plus 1 gives us 4x plus 4. And that's it. This one, we're cancelling down, so we need to factorise the top, multiply to make 6, add to make 5. And this one, there's x in both, so we can take that out and we get x times x plus 3. That cancels with that, x plus 2 over x. Does that cancel further? No, there's a plus. This one, you'll notice it's the same expression as we had before, so this is the same as this, which means it's the same as 7x minus 2 over that. So we go to 7x minus 2 over x plus 1, x minus 2, and as we had from the other sheet, before you multiply across, I would multiply this out. Makes it easier. So this is 7x over x squared minus x minus 2. So then we have 7x minus 2 equals 4 lots of that. This is going to get quite nasty. So bringing it up over here, we have 4x squared minus 4x minus 8 equals 7x minus 2. Bring it all over to the same side because it's a quadratic. We need to make it equal to 0. So we get 4x squared minus 11x minus 6 equals 0. Can we do this in our clever way? Times to make minus 24, add to make minus 11. So we're looking at, oh no, that's not going to work. Is it minus 2? Yeah, it is. I can't do this in my head. I think it's going to have to be, yeah, I'm pretty sure it's going to be quadratic formula. So we do the x equals 11 plus minus the square root of b squared, 121, plus 96, which is 217. Yeah, that's clearly going to be a weird number. All over 2a, 8. And so you get something pretty horrible, which I can't work out in my head, but you know what to do at that point. Right, functions. F of 4. Whenever you have f of something, you replace the x with that something. So instead of 2x plus 1, it's going to be 2 lots of 4 plus 1, and that's 9. G of minus 3, replace the x with minus 3, so it's minus 3 squared minus 7, which is 9 minus 7, which is 2. F of x equals 0, so this is when it's saying, what do we put in to get 0 out? Not f of 0, which is when you replace x with 0. F of x equals 0, so when does this equal 0? Well, if 2x plus 1 equals 0, 2x is minus 1, so x is minus a half. If g of x equals 2, then g of x is x squared minus 7. So when does that equal 2? Well, when x squared equals 9, so when x equals 3 or minus 3. Remember, when you square root, there are two possible answers. Minus 3 squared is also 9. Slightly more difficult now. F of g of x means you take g of x and you put it in f. So if f of x is 4x minus 3, then f of g of x, which is x squared plus 1, we have 4 lots of x squared plus 1 minus 3. You just replace the x with g of x. So we get 4x squared plus 4 minus 3, which is 4x squared plus 1. Similarly for g of x is x squared plus 1, so g of f of x is g of 4x minus 3, which is 4x minus 3 squared plus 1. And we expand that out, we get 16x squared minus 12x, which is minus 24x, plus 9 plus 1, or 16x squared minus 24x plus 10. Some people think you might be able to cancelize this. No, you can't. If this was a 0, then you could start dividing, but that's just an expression. I know there's an equals here, but we are simplifying this down, so do not start cancelling. No. Fg of 5, well, we know what fg of x is. It's 4x squared plus 1, so we can just use that. So this will just be 4 lots of 5 squared plus 1, which is 4 lots of 25 plus 1, which is 100 plus 1, which is 101. You don't have to do all that working, but you get the idea. F to the minus 1 of x. So yeah, people got really confused by this. So f of x is 4x plus 3. So we say y equals 4x minus 3, and we make x the subject. So add 3, y plus 3 is 4x. And divide by 4, y plus 3 over 4 is x. And then we just change this to y to x. So we get inverse function of x equals x plus 3 over 4. And that's our answer. Similarly for this one, y equals x squared plus 1. We rearrange, we get y minus 1 equals x squared. So we can just use the positive square root for reasons which I'm not going to go into. But yeah, whenever you have functions and you need to square it, you just take the positive square root, so then the inverse function is the square root of x minus 1. That's it. So whenever you have a function, you need to find the inverse. If it's f of x is 4x minus 3, you say y equals 4 minus 3, you make x the subject, and then you take the expression with y in it, and you just change the y's to x's, and that's your inverse. Similarly here, we say if g of x is x squared plus 1, we say y equals x squared plus 1, make x the subject, and then whatever it is in terms of y's, we make that in terms of x's. The range is the output, the domain is the input. So if you put 1, 2, and 3 into x plus 3, you could actually use your calculator if you wanted to. Actually, for this one, it's a bit silly, but we could say shift mode, not shift mode, just mode 3, f of x equals x plus 3. Start, well, what was it, 1, 2, 3. So we say start 1, end 3. Can you see this? I have a feeling this is yeah, that's better. Step 1. And there we go. When you put 1, 2, 3 in, you get 4, 5, 6 out. It's pretty obvious. The next one, the calculator is really useful for. F of x equals x squared plus 3. I'm just going to type that in, even though you might not be able to see it. X squared plus 3. Now, the start and end of this one are tricky. We're looking for a domain of x is more than minus 2. So starting at minus 2 and getting bigger. So I'll make the start of this minus 2. And clearly it says minus 2 or more, so it goes on forever, but we're not going to go on forever because your calculator can't do that, so we'll just go up to, like, I don't know, a big number, like 7. And we'll go up in a step of 1. Now, the advantage of this is we know that we're looking for a range of, a domain, of x minus 2. So when you plug in minus 2 into this function, you get 7. But you'll notice the output for minus 2 it's 7, for minus 1 it's 4, for 0 it's 3, and then as x increases, the output starts going up again. And x gets bigger and bigger, the output gets bigger and bigger. But the key thing is, we're talking about the range. So what, sorry, you can still see it. The range of possible values for when you put in values of x which are minus 2 or more. And the range of possible outputs, it goes down to 3 and then goes up again. Now, you don't want to write down all these numbers, because obviously x is greater than minus 2. It could be 2.4, it could be 1.3. This is just to give you an idea of what happens. But the range of outputs is actually 3 or more. So the way we write our answer is we say f of x is greater than 3. I said 3 or more, so that needs to be like that. It's quite a tricky question. And only the calculator will really, well, I say only calculator, a good way of working out what's happening is to plug it into your calculator. Inverse function for this one, bit tricky. We say y equals x over 2 minus x. We've got 2 x's, so making x the subject is awkward. We multiply that 2 minus x over. We expand. And then it's not obvious, but we want to get the x's together and the y's on the other side. So we can bring, actually the easiest way is to bring this over to this side. So we say 2y equals x plus xy. And now we can factorize out the x's. And then divide across. You get 2y over 1 plus y equals x. The inverse function is this thing in terms of the y's, but we change the y's to x's. So instead of 2y over 1 plus y, our answer is 2x over 1 plus x. That was quite hard. Okay, sine and cosine rule. How do we know? Because it's not a right angle. Do we have a pair? No, so this is cosine rule. That doesn't match with that. So we say a squared equals b squared plus c squared minus 2bc cos a. Get off the formula book. Which is our a, the one we're trying to work out. So x squared equals 5.1 squared plus 6.7 squared minus 2 times 5.1 times 6.7 times cos 85. That's all going to get a bit messy. I'll just work it out on my calculator. And you get that. 5.1 squared, 6.7 squared, 2 times 5.1 times 6.7 times cos of that equals all those numbers. You end up with 8.06. For this one, you do have a pair, so you can use sine rule. Because it's the angle at the top, you say sine x on the top over the opposite side equals sine 85 over 4, and then you multiply that 3.5 across, so you get sine x equals 3.5 sine 85 over 4. So x is the inverse sine of that. I'm going to just work it out and tell you what the answer is. Actually, no, I might as well show you how I type it in. So I'll do shift sine and then brackets and then 3.5 sine 85. You need to close your brackets because a trigonometry function within a bracketed expression doesn't work. Over 4, right click, close bracket, equals 60.6, or 60.7, sorry. There you go. Right, with this one, find the size of the angle. So again, you have no pair of angle and side, so we need to put this in. I have a feeling this was C, C, and 18C, 15C, and 21C, but it doesn't really matter actually because all the C's will cancel out in the end. So we use a squared equals b squared plus c squared minus 2bc equals a. Sorry, I almost wrote it down wrong. And our a this time is the angle, so we can use the rearranged version, which is b squared plus c squared minus a squared over 2bc. And so we're going to have, that's going to be our A, obviously, because if that's our A, that's our A. So this is B and C, or whichever way around. We get 15 squared plus 8 squared minus 21 squared over 2 times 15 times 8, which is minus 19 over 30. And if we do cos to minus 1 of minus 19 over 30, we get an answer of 129.3 degrees. For the area, we do half AB sine C for each of the two triangles. So we do half AB sine C for one, we do half AB sine C for the other. Now, because it's a parallelogram, it wasn't in that other question we did in class, this 129.3 is going to apply to that one, and it's also going to apply to that one. And in fact, we can make this a bit easier for ourselves, because this triangle would be half AB sine C. When we say half AB sine C with this, we're talking about AB as being two sides either side of an angle C. So which is the known angle? It's that one, that's our C, that's our A and B. So it'll be half times 8 times 15 times sine 129.3. But because we're doing half AB sine C and then another half AB sine C, we're doing two lots of that, which is just AB sine C. But I'll make it the slow way. So it's a half times 8 times 15 times sine 129.3, which is, I believe, 46.43 times 2, which is 92.9. Okay, final question. I'm going to have to leave this one because you have to go, but hopefully that's enough for you to go on.